Okay, so in charging by friction, movement of electron is happening, and when you go through this definition, okay, when you go through the statement, so the one thing that you should be asking is why it is happening. So I gave you the reason for that also. The holding capacity of, like in this case, we will take a rhombus. Okay, so this is a rhombus right now. So the holding capacity of rhombus is less than the holding capacity of, this is hexagon, correct?
Yes, sir.
Okay, of rhombus is less than hexagon. That is why it is moving from rhombus to hexagon. Is that clear?
Hexagon. Yes, sir.
Okay. Now over here, you need to understand one thing. Okay, that that only you need to understand one thing over here, that only electrons are transferred. Only electrons are transferred, no protons. Okay, only electrons are transferred, no protons. Protons are completely safe and locked inside the nucleus. Okay, is that clear?
Yes.
What are transfer? Only the
Electrons.
electrons. Okay, now the very important topic that is coming in the next part is, okay, so I'm going to write it over here. Is the listen over here. Now charge by friction. So this charge is basically done when there is a physical contact. When there is a, you need to
Physical
rub,
contact.
you need to rub two things with each other. The next part is we are going to do charging. We are going to do charging by induction. We are going to do charging by induction. That is again, okay, charging by induction. Now, what is charging by induction basically? So look over here. Basically, over here also, you are going to charge a conductor, okay, with a charge product, but there will be no physical touch. There will be no physical touch. Is that clear? Is that clear, Jian?
Oh, yes,
So,
sir.
this method, you can say this method also charges the conductor without physical contact. Without physical contact. Is that
Contact.
clear? Without physical
Yes, sir.
contact. Okay.
Yes.
I'm putting this, I'm bringing this over here, and we can increase then for us a 28 doesn't increase. So this method also charges the conductor. There's no doubt in that, but without a physical contact. Okay. Now we'll go with this step by step process, like how it happens basically. Okay. So if you like suppose bring a charge rod close to a insulated metal. Okay. So if the rod is negative, okay, then in that scenario, the sphere give free electrons. Okay, because we are talking about a metal sphere over here. Na? So what I will do is, for the visual representation, we will draw one figure over here. So this is metal rod, okay, and this is suppose charge rod. This is charge rod. Okay, okay. Now the thing is that if you bring a rod close to the uncharged, now over here, the metal sphere is the uncharged one and the rod is the charged one. So if the rod is negative, so it will repel the electrons, free electrons of sphere to the far side, leaving the near side positive. Now what is happening over here? Look. Jian.
Yes.
I will just make it little bit bigger. Just hold on for a minute. Just make it little bit bigger so that okay, suppose that we are bringing it over here. Okay. Now the now the thing is that over here we have got all negative charge. Negative, 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 negative. Okay. Now what it is doing is basically due to this negative charge of sphere will go backwards. Correct?
Hmm.
Because same charges, what it does, it repels each other.
Repel.
So when the negative charges are moving backward, that means the only charge that will remain at the surface will be the positive charge. The only charge that will remain on the surface will be positive
Positive charge.
charge. Okay? And due to that, that side of the sphere becomes positive in nature. Okay?
Okay.
Now, the repelled electrons basically escape down your finger to the ground. Now, what happens is suppose if you are holding that sphere in your hand, so the electrons will move into your body and it will go down into the earth. The same concept is being used for earthing also. You know, na earthing? Like we have got 3 pins. How many pins are there, Jian?
Huh?
We have got
I don't know
three.
what earth then.
Okay, so basically, if you look at this switchboard, you will look 3 pins over here. One, two, and ऊपर की तरफ there is a बड़ा वाला. Correct?
Hmm.
Right now also over here it is there. Black color में जो मैंने लगाया. Ikra is also having red color का with her. Correct? So तो हमने इसके अंदर plug लगा दिया है. ठीक है? If you look over here. Oh my God, sorry. Look, can you see
Oh,
this?
this.
So the
This.
so the upper one is for earthing, and these two are for one is for life, another one is for neutral. Okay. So what is the job of earthing over here is it does the same job. Like suppose if earthing is not there and you are using any metallic appliance. Okay. So kabhi kabar you will get a shock. Okay. If it comes in contact with the surface. What does earthing do is earthing basically take that electricity and it push it towards the earth. That is why it is called as earthing. Earthing. Okay. Now the third part is if you remove the earth connection while the charging rod is still held in place, then the remaining positive charge in the sphere will remain as it is only. Now what is happening over here is if you are still holding the ball, that sphere in your hand. Okay, if you are still holding that in your hand, okay, and if you remove the earth connection, okay, so what happens now is basically the rod will be positively charged. Now if you remove the charged rod, then the positive charge redistribute themselves evenly over the surface of the sphere, and because of that the surface is permanently positive charge. See, there are 4 steps over here. Jian, try to understand. The very first step, it was that we are taking a negative rod and a sphere. Negative rod and a sphere. When I'm bringing the negative rod towards the sphere, so sphere के negative charge will repel from that area. They will be like, नहीं नहीं हमको we can't stay with them. Correct? Negative cannot stay together. So they will move backward. Since they are moving backward, then the only charge that is remaining over there is positive. Is that clear? Okay. Now the thing is that if you are holding that sphere with your hand and you are standing, suppose your legs are on the earth, so the electrons which are repelled, they basically transfer from that ball to your body and then it will go down. Okay, so our body also gets charged. If you notice in winter season, this mostly happen. If you are wearing any woolen clothes, so you will feel like a sparkle wala thing. That is nothing but and static electricity is also danger. Huh? Like I used to think like static electricity was simple. Like even our battery cells are all static electricity. But then I saw one video where a person was sitting on some cotton or woolen clothes in a truck. Okay. And since the truck was constantly moving, so he was like it was driving, so he was also moving with the truck. So that causes the friction. And the moment the truck stopped and he jumped from that roll of a woolen cloth onto the truck, suddenly there was a blast because of that electrostatic force of energy. Not a blast, you can't say it a blast, but there was that fire coming up. If I get that video on YouTube, now definitely I will send it to you. Okay, Jian, is that
Yes,
clear?
sir.
So induction is nothing but where you are definitely charging the object, but in this scenario you are not touching it. I have just brought the rod close to the sphere. Okay. Now the first step is we need to bring it close to the sphere. The electrons will repel, only the protons will remain. Second, since I am holding that sphere in my hand, that repel sphere will go down from my hand and it will go down into the earth. Is that clear?
Yes,
Okay.
sir.
Now after that you remove the hand and you keep those two rod and the spear in the same position. Now धीरे से remove the rod also. So now only the positive charge will remain on the spear and it will distribute evenly and it will become positively charged. Why it become positively charged? Because listen, एकदम simple logic है. Because by bringing this rod near to the spear, what you did is you made the electrons all escape onto the earth. What you did? You made all the electrons escape into the earth. Is that clear?
Oh, yes, sir.
Without touching, without rubbing, you have just brought it nearer. Nothing else. Okay? Is that
Uh,
clear? Any doubt?
yes, sir. No.
क्वेश्चन 5 में मिरर है या लेंस है?
Huh? What?
क्वेश्चन 5 में मिरर थोड़ी आएगा,
फिर?
लेंस आएगा ना.
Okay.
यहाँ पे
चलेगा.
मिरर है,
तो लेंस डाल दो आप.
डाल दो. ठीक है, हो गया मेरा तो.
Complete paper? Yes. Now, yes, Jian, tell me what you studied in that part, what you understood. You need to now explain me.
That
I am the student and you are the teacher. Now kindly explain me what is friction and charging.
yeah.
What happened?
My sister had to scream and asking me for some.
Screen.
She needed a pen.
Okay. Yes, tell me.
Uh, what do I have to explain? So, like what I read?
Yes.
Hmm. Not really putting. Don't know how to explain it in my own words, sir.
Ah, chalega. Explain in your own words. That's
Yeah.
completely fine.
No, uh,
Oh.
Friction is caused by the rubbing of two things together. For example, a polyethylene uh, and uh, when you, for example, you rub a rod and a cloth, you the electrons from the cloth
Oh,
will go from the cloth to the rod.
okay. And
Then
after that,
Can I go?
are you done with the test?
Yes,
Wait, hold on for a minute. मुझे आप देखने रहे हो. Have you submitted the test?
yes,
Yes, you can go. All the best.
okay.
Yes, Jia. I think so. I explained you the scenario. I am the student. You need to explain it in a much better way, beta.
I know, sir, just I'm not that good at explaining.
Okay.
Speaking is not my strong suit.
Okay, but what do you understand from that part? What is neutral?
Neutral is when like the there's a positive and negative in like equal measure. So like there's same amount of protons, same amount of electrons, and it's
Okay.
no
Acha,
charge.
just tell
It
me why
cancels out in
only
no
why
charge
only the outer electrons are moved? Why not the inner one?
because they are strongly held together by the protons and neutrons in the nucleus, and as you go farther out from the farther away from the nucleus, the bond only gets weaker and weaker. So it's easier for the outer electrons to get let
Okay.
go first.
Okay. Now the next part is I want to understand what is when will the object becomes negative? Marjian,
But
when will the
sir,
object
you
becomes
cut off
when will the object when will the object becomes negative?
when when it gains electrons.
When it
Gains
gains
electrons.
electrons. Okay. So it will become
Negatively charged.
negatively charged. Okay, that's fine. How many materials are required to generate static electricity?
Two.
Two. Okay. Why doesn't it happens in the insulator?
Because they don't allow this electrons to flow as freely as conductors. So it's not possible for induction insulators to conduct static electricity.
Okay. Have you read the conductor and the insulator part?
So you only said friction and charging. So I was debating on whether I should read the conductors and insulators. So
No,
it
because
falls
the
there.
last question that I asked you was on conductor and insulator part actually, and you gave the right answer. No problem.
Mm,
You gave the right answer. So I thought might be you have gone through that also. No problem. That's completely fine. Chalo, quickly go through conductor and insulator now fast. 3 minutes.
Done, sir.
Eight 554. Hold on for a minute. Are you done?
Yes, sir.
Chalo, perfect. Very good. Okay. So the next question. Okay. What is an electrical insulator?
An electrical insulator, like the objects or the definition?
Definition. And you can give example as object also.
Electrical insulators are substances that doesn't allow the flow of electrons because they are tightly bound together.
Okay.
And some examples are glass and plastic.
Okay. Now just tell me one thing. If I'm rubbing a copper rod, okay, so what will be the flow of electrons?
From the cloth to the rod, to
Hmm.
you, then
Hmm.
earth.
Correct. From the cloth to rod to me to earth. Okay, that's how it will
Yes.
move. Okay, so suppose if I am rubbing a polythene rod on a cloth, okay, so what will become negative, rod or cloth?
Uh, the cloth.
Okay, perfect, very good. That's perfectly correct. Now, the next important part is electric field, correct?
Yes.
Electric field. So, can you just open your book, page number 315?
Yes, sir. Yeah, I opened it.
Okay, so if you look at the figure, there are three figures shown over there, correct?
Yes, sir.
Okay, so basically, whenever an object is charged, it will be always surrounded by an electric field. Okay, and if a
Yes,
charge
sir.
object moves into a electric field of another charge object, then it will experience a force of attraction or repulsion. Now it's very simple. Like suppose I have kept a mobile over here. This is a charge object and this is an uncharged one. So it will not have an effect. Both will be stable. But the moment this is a charged one, I am still bringing both of them together. Now they will become unstable. Now they will become unstable.
Yeah,
Now how will they become
unstable.
unstable? How they will behave? Either they will attract if they are oppositely charged, or they will repel if they are same, like both same charge. Okay, is that clear? Okay.
Yes, sir.
Now, if you look at the diagram, the lines of force are basically, you can see it is coming out from the positive charge and it is always going
And
into the negative charge. Okay, why? The reason behind this is we always indicate the direction of the force on a positive charge place in the field. Okay, we always show it on the positively
positive.
charged field. That means the flow of force will always be from the positive charge. It will be like the source will be from the positive charge. Okay.
So this reminds you of exothermic and endothermic.
For example, in what way?
Uh, positive. The charge is exothermic, so it's like releasing,
You
and
can consider it in that way.
endothermic.
Yes. Kind of, you can just try to memorize it in that way also. That's completely fine. But other than that, they don't have any relationship. Okay.
Yeah.
Okay, now if you look at the third object, so they have given you the third object also. Over there also you can see the force of lines. There are two rods. One is positive, another one is negative. And the force of line and the force of line are passing from the positive to the negative. It is passing from the positive to the negative. Is that clear?
Yes.
Any doubt up till here? So you can ask me, please.
No, so there's no doubt.
Are you sure?
Yes, sir.
Okay. Perfect. Very good. Any doubt up till here, Jian?
So
Do you think the chapter is easy?
yes, it's just like magnetism.
Yes, exactly. This is a easier chapter, so I want to finish it in this session only. That will be much better. Okay.
Okay.
Mostly what I did is in the initial part of the session, I explain you all the topics. Correct. And then we are just going it into the deeper details. If you look at this white